Alright, let's solve this logarithmic equation from the homework. There are two ways to solve this, and I'll actually solve it both ways so you can see which one is easier, but I'll start with the easier one first. First thing I notice is that the log of 6 base 6 is equal to 1, and so that makes this a little bit easier right there, because I now have a log equation where I have a log on one side and a constant on the other. So my goal is to isolate the log expression and then change to exponential form. So I do that by dividing both sides by 2. So I get the log of x plus 2 base 6 is equal to 1. Rewrite it in exponential form. So it's just 6 equals x plus 2. Subtract 2 from each side, you get 4 is equal to x. When you check this, it works, but we'll check it. I've got 6 log 6 of 4 plus 2 equals the log of 6 base 6 plus 1. So I get 2 times the log of 6 base 6 equals the log of 6 base 6 plus 1. Now I can evaluate the logs, so I get 2 times 1 equals 1 plus 1, so 2 equals 2, and you're done. So if you recognize that, if you simplify any logs or evaluate any logs that you can, you sometimes can solve a problem in a much simpler way. I suspect that you may have solved this and created an exponential equation, which is not wrong, or a quadratic equation, excuse me, but it's just harder. So let's try it that way also. And so if I didn't, I still have to change this. I still have to evaluate it in order to get this problem done. So that's still equal to 1. So I have 2 times the log base 6 of x plus 2 is equal to 2. So maybe you didn't recognize that you needed to divide by 2, and instead you brought the exponent up, which is legal. It's certainly a strategy. And we still want to write this in exponential form, only now it's going to be 6 squared is equal to x plus 2 squared. Right? So evaluating or simplifying each side, I get 36 is equal to x squared plus 4x plus 4. It's a quadratic equation, so I want to get 0 on one side. That would be minus 32. From here you can use a quadratic formula, or this one is factorable. So I'm going to have x times x. I need a negative last term, so I know I need a plus and a minus. It's going to be a positive 8 and a negative 4. Setting each of those equations equal to 0, I get x is equal to negative 8 and x is equal to positive 4. And so negative 8 is not a solution, not simply because it's a negative, but because when we take negative 8 and we substitute it in the original expression, we get a negative argument, which is not, negative numbers are not in the domain of logs, and the x equals 4, which we already checked, does work. So you get the same answer both ways, and it really just comes with exposure. I would guess that the first time I ever solved a problem like this, I probably did it the long way, and now that I've been teaching for a very long time, I tend to notice things that a student might not notice the first time. So I hope this helps. Let me know if there's anything else I can clarify.